Okie dokie. I am Jeff Kant. My name is Arcalis on IRC and GitHub and Twitter and things. I am, in fact, a New Zealander, and I did write upside-down systems in the bottom of the world. At the moment, I'm an Erlang engineer on Heroku's routing team. I'm an engineer, as opposed to many of my previous jobs where I was the engineer. So that's exciting. So yeah, like a few of the, these are just the systems I've written that have made it into production. And I have the scars to prove it. So yeah, the first one at the top there is possibly one of the most fun things I ever did. It's the project that I first managed to sell my bosses on, talking to a client about. They wanted a network protocol translator, but the wrinkle was that it had to run on a scientific research ship that sails between New Zealand and Antarctica and does all kinds of complicated science, unlike that computology that I do. So yeah, anyway, and then there are a whole bunch of other things. As you can see, I did eJabberD for a little while, and then wrote a custom presence and messaging system. Don't know if anybody can relate to that. And yeah, so now for Heroku, I work with my boss, Jake Veruda, on our routing layer, which routes every single HTTP request that goes through Heroku, and our syslog router, which is called Logplex, and that routes all of the logs that happen for every single component at Heroku. Okay, why do I seem so bitter on Twitter, in case anyone has subscribed? Well, so I think somebody alluded to this in an earlier talk. I think it was Mahesh who said that they had this third-party library and it was doing God's work. But the problem is that you never stop to ask which God are we talking about precisely. Production is cruel, fickle, etc., etc., etc. So I guess my definition of production Erlang systems is that they are designed for 24/7 operation. People hate downtime on it, and either you are not allowed to have downtime, or the process of scheduling the downtime is so painful that you would rather just not have to do that. And if that means that you stop for like 27 milliseconds in the middle of something, that's probably okay. But stopping for like an hour is going to mean 6 months of paperwork. So the other thing is you need to like the people who are on call for this system, either because it's you, or you are friends with the ops team. And if you have an ops team who is on call for your software and you don't like them, then you're a terrible person. Yeah, and production systems, they are tricksy like hobbitses. They steal our precious sleeps. So this is the reason that I'm still writing Erlang, is because I think about trying to run production systems in other languages. I did a bunch of Perl before I did Erlang. I did a bunch of Java. I did C#. Did a few different things, but there was kind of a common theme of, like, if I was trying to write some kind of daemon that had to run for a long period of time, it would get into production and then it would run for maybe a day, and then it would go weird, and then we'd chrono restart, and then I would cry. So Erlang, like production systems, you need to be able to debug them, and the only place that they behave like production is in production. Any other environment is full of lies. Once you've figured out what the problem is, you need to be able to fix it, and preferably without 6 months of paperwork. It really slows down your compile, edit, debug cycle. And what this presentation in particular about are techniques that I have slowly and painfully learnt that are pretty widely applicable. Like, these are things that you can do without access to custom code or fancy projects or debugger things that you download from the web and so on and so forth. This is the tool bag that you will need, and that's not talking about me, you jerks. You will need a remote shell to your Erlang node. Like, that's kind of the bonanza from which everything else springs. Really, difficult requirements here. You need a terminal emulator with copy and paste. If you're still using magnets on the end of the Ethernet cable, it's time to upgrade. So the two ODP applications that are part of the standard distribution have been there since before I was writing Erlang. You need observer and you need runtime tools, and that's very oblique, and you have no idea what's in them because, frankly, those names are non-descriptive of what they do. Okay, so debugging your Erlang system while it's in production. Anybody wanting to do experiential learning, feel free to get on the Wi-Fi, log into your production systems, and follow along. So, getting a remote shell. This is the single most powerful tool in your toolbox. Make sure that you have the ability to get a remote shell to your production system, or you may as well be writing Java. So in this case, I have the standard command line invocation where there's a machine on the network with a node name of broken at my laptop's local name. And it uses a cookie of test secret codes. And when you're doing a remote shell, there are two nodes involved. There's the node that you're trying to debug, and then there's the local node that you're typing things into. And both of them need names because this all runs over Erlang distribution. So I usually name my shell as myself so that A, I don't get a name conflict if somebody else is trying to debug the same system at the same time, which now that I am an engineer instead of the engineer is a thing. Also, so I don't get confused between tabs if I get two shells onto it or something crazy. So anyway, yeah, you can do all of that from the command line. You start it up, and you notice that, like in the bottom of the example, the node name is broken, which is the thing we're trying to debug, and not Jeff, which would be the shell that I type into. So yeah, there you go. That's all you need. So the other thing is the Erlang shell has this weird drop control mode that you can drop into if you hit Control G, and it gives you this weird little menu of like, I don't know. I think they are documented somewhere, but I've never really found it. If you type H and press enter, I believe it gives you some sort of cryptic little hints about stuff. The two that I use, well, I guess I use a couple of them now. J, enter, in the little JCL thing, gives you a list of the currently running jobs, and C, and then the number of the job will let you switch between them. So you can actually have your little local node that you type into and have multiple interactive shells running on it and switch between them. And the extra cool thing is that if you use R instead of S to start one of these things from the little JCL prompt, you can get a remote shell. So you can do things on the local node that you're typing into in case you need to like grab some files off of disk or something if you're going to do something really crazy like net load a code using literals. Or you can switch back to your other one. Or if you're debugging multiple remote nodes at the same time, you can use this to use like one terminal to have access to multiple things at the same time. So that's two different ways to get the same little remote shell. So what do you do once you have a remote shell? Well, sometimes you're going to have, there are like a whole lot of functions in the Erlang module that are fantastic for debugging. I would suggest sitting down and reading the entire manual page for the Erlang module. Just read it all, top to bottom. There's all kinds of gems in there. You'll go through, and if you don't find at least 3 things that you didn't really know about, unless you've done this recently, that you go, hey, I needed that 2 months ago, or holy moly, that'll be useful the next time I run into that, I would be very surprised. So process info is fantastic, gives you information about a process, who would have thought. There's lots of stuff in there, and you can get each one of those little items out in particular by using the 2-argument version where you give it a process ID and the thing that you want. So you can say, give me how much memory this process is using, or give me the size of its message queue. Size of its message queue, a very important metric. So the other thing that you might have, or should have, are log files about what's currently exploding in your production system. And there will be a bunch of process identifiers in those log files. And what you may have already figured out for yourself is that when you copy that PID out of the log file and paste it into the shell, you just get syntax error. That's because PIDs are not readable because Robert Verding, rah. Go away. In fact, I'm turning my Wi-Fi off. Right. OK, so the way that you get around this is that there is a 3-argument function that is in the default shell namespace called PID. It takes like those 3 numbers that you see between the angle brackets and the periods. You put those in as integers function arguments, and it will turn that into the right PID for you. And it doesn't matter if the PID is alive or dead, it will give you that PID. It works for remote PIDs and it works for local PIDs. The other thing you can do is list to PID, where you take a string containing that PID that you got in the log file, and that will turn that into a PID too. That one is longer to type, which is why I don't use it. OK, so now that you have this remote shell, you have this fully programmable debugging environment directly available to you. So you can go and ask the system questions. And you can ask them in Erlang, which you already know how to write because you wrote some code before you deployed it to production. So here, what I'm trying to do is find the process ID of the thing using the most memory, because that's one of the totally garden variety problems that production systems have. So connect to the remote node. Then this code you may just want to come back to on my slides when you read them on the web or something. But essentially, there's a function called Erlang processes, gives you a list of all the PIDs in the system. We iterate over all of those and call process info of that PID, comma memory, and we do it in a list comprehension because I don't like writing the anonymous funds for map. And then we sort the list by that memory thing that we got out. We turn the list of processes into a list of tuples of process ID and how much memory it's using. And we sort it in order of memory. We reverse it because the sort was in the wrong order. And then we take the first one off the list. And you're going, OK, well, that's kind of a bit of a mouthful. So the other thing you can do is you've used the shell before, and you know that you can't write actual functions or actual module code in the shell, which also, whoever's responsible for that one, so you have to do everything with anonymous functions. So it's once you get used to the process of writing it, it's like writing in a different programming language, which is a very close cousin of Erlang. You just need to know that they are not the same thing. So in this case, I turn that little snippet of stuff that I had before, I just wrap it in an anonymous function, and I assign it to a variable, and then I can run it from that point on. Now, the cool thing about this is that if you write it, you can then copy that and save it in a text file and put it in like a gist on GitHub or in a big collection of the things on GitHub. And you can just paste that straight back into a shell the next time you want it, and then that function is available to you. So I actually do a lot of debugging this way. Like I write a snippet that gets me a thing that I want, and I go, hey, I'm going to use that again. And I put it inside a little anonymous function with a name, and then just keep that in a file. And then the next time I need it, and I have shellcode things that are like 3 pages long that I paste into stuff. I have no idea how they work now, but they seem to do the right thing frequently. Anyway, so collect snippets, pro tip. I have a big collection of them that I use myself, and they're available under my GitHub account in a repository called eShellcode, and they do all kinds of crazy things. There's very little documentation. I think I started putting a little one-line document about, well, I say document, I really mean a throwaway sentence about what the rest of the thing does or is used for, that sort of thing. OK, so moving quickly on. Post-mortem debugging. Erl crash.dump files are not the completely useless blobs of indecipherable nonsense that I thought they were, taking up my valuable IOPS if you're on EC2 like me. They will, when I get a free moment at Heroku, I will build a service that, before starting my Erlang node in my little upstart script, if there is an Erl crash.dump file, I'm going to take that file and I'm going to put it in S3. Because once I discovered the magical tool called Crash Dump Viewer, don't open those things by hand, no point. maybe read the banner message and you'll learn that there are a couple of things that, A, there's no point in debugging. Like if it says crashed in init do boot, just give up. Like you're done. That stuff is useless. But if it was a runtime crash because of out of memory or some other fault like that, the crash dump is the best thing that you can have because it captures the entire state of the system. All of the little processes, their stacks, their message queues, all of that is available to you. The crash dump viewer gives you a web interface to it, so it's actually possible to do the thing. And here is one that I prepared earlier, taken from an actual honest-to-God production system, which ran out of memory and then blew up. Okay, so you see this thing and it says can't allocate some ridiculous amount of memory, and you go, yeah, all right, cool. Processes, all right, well, we've got like a jillion of those. That's all good, all right. Now if I click on stack, oh, look, there's my problem. The process using like 1,000 times as much memory as anything else, and it has a bajillion messages in its message queue. So at that point, you know that some process being used by a lot of other things stopped working, and its message queue filled up, and then you ran out of RAM. So if you actually click on it, you get a little bit more information about it. How much you get is dependent on the state the process was in when the node blew up. In this case, you know, this will always be the way. The process that you want the state of will always be in the state garbing, so you won't get the complete stat trace and the other niceties that you get if it wasn't in the state garbing. But anyway, just finding out that like the function that it was last scheduled in for, which I think is a magical new thing as of 15 or 16 or something, but knowing who it was spawned by, if you get its process dictionary, like you get clues as to the identity of the process that has zillion messages in its message queue. And in most Erlang systems that I've ever seen, there's usually a really small number of ways that a process can get a zillion messages in its message queue. So that usually gives you enough that you can figure out what the problem is from there. So rather like Crash Dump Viewer is this web tool application that you can start up and you browse to, and then you upload a crash dump file and blah, 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 blah. But if you're paying attention, you know that uploading that crash dump is anywhere up to like, you know, 15, 18, 22 gigs worth of data. That doesn't work at all. What you want to do is you want to copy the file to the system that you're running Crash Dump Viewer on, which I often do on my laptop rather than the production system, because you don't want it to use up all of your RAM and, you know, badness ensues. So I have this snippet, which is in the eShell code repository that I mentioned, called Crash Dump Viewer. And what it does is it hype compiles a couple of modules so that the Crash Dump Viewer runs faster. It starts web tool, which is a dependency of Crash Dump Viewer. Basically, you paste this into a console, and you get a function called load dump, which takes a local file name and makes Crash Dump Viewer load it. And this is something that I should really submit a patch to OTP to add this as like an exposed API documented function thing. But when I wrote it, I didn't have time. So it's a nasty gen server call that happens to work because I read the code and know that it does. All right, live demo, covered that. So moving along again. What is eating all of my CPU time or compute units if you're in EC2 land? If only there was a top for Erlang. Well, fortunately for you, OTP includes ETOP. Now, I know there are fancier replacements for ETOP. There's the one that comes with Redbug, which is like DTOP, and then there's like NTOP or something rather. And they are better. Both of them are better. However, ETOP will be there if you have a standard OTP install, and it's there all the way back to some pretty ancient versions. It's pretty hideous. Like when I say it's like top if you take out all of that fancy terminal manipulation that gives you a screen of updated lists. This just prints out the same screen, and then it prints out the screen again, prints out the screen again. So I usually set lines to whatever makes it fit an entire page on my terminal and font size. My terminal is always the same size for some reason. Those magical arguments are not particularly well documented. But if you look at the slide, you really only have to give about three options for it to be really useful in a remote shell session. And the cool thing about it is that if it's somehow tied to the output node that it's displaying to, so if you kill your little remote shell session, it cleans up all of the ETOP tracing stuff on the server. So basically, if you kill your local shell, it cleans up the production thing that you were debugging. So in this case, it's showing you, I think, 10 PIDs, the current function that they're doing, the number of reductions since the last time this little ETOP page printed out, and the amount of memory they're using, and some other stuff. Really, all I use this for, I sort by memory and I sort by message queue size. When I sort by message queue size, I'm looking for the thing that has more than about 10 messages in its message queue. Because anything that has more than about 10 messages in its message queue is a bug. And also sort by memory, it's a really quick and easy way of finding out who's hogging all of the memory in your system. If you find out that you have like 100 nice, evenly distributed memory hogs, then you really have a problem, because that one's hard. If you find that you have one process hogging like most of the memory, that one's usually easier to fix. Okay, take a big, deep breath. I'm going to take a drink of water. My attorney advised me to take a small drink out of this bottle here. All right, the interactive debugging, or why there is no good standard log system in Erlang. Why doesn't Erlang have log4j kind of thing in it? It's because it has tracing. And so the Ericsson guys who've grown up with the trace capability and know how to use it, probably, I'm guessing very, very strongly here, that they learned by sitting next to somebody who either wrote it or had learnt how to use it from the person who wrote it. And so the oral history went on and on and on, and you learned how to use DBG. Because let me tell you, learning how to use DBG from the manual alone is a painful business. But it's very, very useful. I guess in a nutshell, I would describe Erlang's tracing facility as a way to dynamically subscribe to messages which the system will send you about events that happen to processes. That's quite a large nutshell. Processes are doing all kinds of things all the time. They're garbage collecting, they're getting scheduled in and out, they're sending and receiving messages, they're calling functions, all of that kind of stuff. And all of those things that I just said are events that you can subscribe to with the trace system. The tracing functionality is fundamentally exposed in the Erlang module with trace flags, trace patterns, and a couple of other functions starting with trace. But they are really cryptic and harder to understand and use, I think, than DBG, which is really saying something. So DBG is the non-graphical, because there is like a whole graphical debugger in Erlang, which on your local machine is really awesome, and trying to use it in a remote exterm across the network when you have a Mac is hard. So I use DBG because it is text-based and doesn't require a whole bunch of X stuff to be installed. DBG is also handy because it will let you set up distributed traces. So you can run the same little set of, you can control the debugging and tracing of an entire cluster from a single like remote shell thing. So that's pretty neat. I have this diagram. So there are kind of two kinds of messages that you'll get sent. If we're talking about function calls, they happen so often that the Ericsson team decided to build filtering into the tracing language so that you wouldn't just turn on tracing and then your node falls over and stops working. So the trace patterns are for function call tracing, and they let you filter down the kinds of things that you are interested in so that you don't get overwhelmed and the system doesn't spend all its time generating useless trace messages. The other kind of messages are about processes themselves, sent, received messages, garbage, scheduling, that sort of thing. Those there are no filters for, so you don't need to worry about trace patterns, as they're called. The other thing is tracing by default applies to no processes. You have to specifically say, I want this kind of process or this particular process. I want to flag it for tracing of these kinds of things: sent messages, received messages, all messages, process events, that kind of stuff. So that's the setup for tracing. And then what happens is the runtime system, when any of those things occur, it sends the guy who is responsible for the tracing, called the tracer in DBG land. That is a process, and it just gets sent this stream of async messages that you subscribed it to with the other DBG commands. So that was actually quite a good diagram. This is one that I wrote to describe our logplex system, and as you can see, I would probably fail first grade. Okay, so the basic process of using DBG is you set up a tracer. The tracer is responsible, it is the thing that receives all these trace messages, and it needs to translate them into a form that you can use. So it needs to receive these messages, and then it needs to print them to your equivalent of standard out. You need to, before you turn on tracing, you need to decide which information you need, and you need to have some idea of the volume of trace message that this thing is going to generate. So when you turn on tracing for calls, don't just trace every function call that could possibly exist in all of existence all at once for all processes, because your production system will just stop. And then 6 months of paperwork describing why you won't do it again. So if you're going to do call tracing, always set up trace patterns. Do it on like a particular function for a module, or a particular module if you know that it doesn't get called like in a tight loop all the time, that sort of thing. And if you're doing message tracing, again, tracing a process that is like the fundamental like synchronization point for something in your system, like tracing the MySQL process. If you only have one MySQL connection and you're doing 10,000 things a second, probably going to blow up your tracing console. So be very careful about doing that. One of the things you can do to get around that is to turn tracing on for a very short period of time. So you can call this function, which I haven't really explained here. DBGP is where you flag a process for tracing. So what you can do, because you're in a shell, you can write a statement that is like DBG turn on the tracing for all of the zillions of things that this is going to generate for this process, comma, sleep, time asleep 1000, do it for a second, and then DBG stop clear. Like run for a second and then turn off tracing. And then you can just leave your console to finish like outputting all of the bazillion things that you just got sent. Okay, so the easiest tracer to use is the one that is the default. You get the default output and message formatting. It's the standard one in OTP. You get it by doing DBG tracer. And that's great, but it doesn't work in a remote shell because So what I figured out that you can do is this thing at the bottom, which looks complicated and weird, and really it is. It took a frustrating length of time to figure out that I could, in fact, do that. Basically, it runs the standard tracer in such a way that it works in a remote shell. So if I can do it, then why isn't it in the standard library? Because I'm lazy and I didn't submit a patch. So this is me tracing messages to the code server on just a shell, on a system doing nothing, and then I ran the command load biscuits, which is a module that doesn't exist. And there are a bunch of messages, and the default output looks like this. You get the PID that's doing something, and then the little sidewaysy arrows, I think, is a receive. And then the thing below it has a bang in it, so it's sending to that process. There are a whole bunch of different things that it outputs. So you can get fancy with it, because that little function that I put in the slightly more complicated tracing argument, you can write them yourselves. All you have to do for that one is write a function that's compatible with DBG. So it's a 2-argument function. It takes a trace message and the current state of the function, and then does something with the message, presumably prints it, and then returns the state. Often I don't actually have any use for the state, so I just pass around undefined. And then the trace message in there, I format the thing. I put in a human readable timestamp by using the calendar module, and I format sends and receives nicely, and turn a tuple of MFA into something that actually looks like the Erlang syntax for a function call. It's just like you write functions that will call IO format with the right things, and then throw the trace messages through it. So I have a whole lot of example traces in that shellcode repository on GitHub. Okay, so get to the good bit. Calm down. Don't trace the tracer, because that's feedback. And if your production system may survive, but it's not guaranteed, your local console, that's completely gone, so don't do that. Don't trace the IO system that is connected to the tracer, because that is the same kind of feedback and it will blow up in the same kind of way. Estimate how many trace messages your patterns will produce, and if it's going to be all of the messages, don't do that. DBG stop clear cleans up all of the thing. It deletes all the trace patterns, turns off the tracing on all the processes, shuts down the PID that was collecting the trace messages so that any outstanding ones get thrown away, all that kind of thing. Yeah, I use that one a lot. So because this is a shell, you may want to trace groups of processes. So often your processes are arranged in some kind of hierarchy because you're being good and using OTP supervision. So you can say, turn on message tracing for all of the children under this supervisor, and it's just yet more shellcode, which once you have slowly and painfully figured out, can turn into an anonymous function, stick it in a text file, and then never have to figure it out again. Yay. Call tracing looks a little bit like this. The function TP with an ever-increasing number of arguments. It starts with module, and then function, and then arity, and then the last argument is always a match spec for how to filter the arguments for that function. So you don't actually have to trace on every invocation of a function call. You can say, I'm only interested where the first argument is 1, and the second argument is anything that you can express in a guard, basically. Ha 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 ha, nobody actually writes match specs. There's a function much like ets has fun to ms for writing the match specs for an ets select or amnesia. DBG has its own variant, which is DBG fun to ms, and it just has a few extra things that you can do, like return trace for when this function call returns, send me another message about that as well. So you'll get a message when something enters the function and when it returns from the function. So at this point, you should realize that if you were to write some horrifically complicated shellcode, you could do call timing based on that. Because you get a message when you go into the function, and you get a message when you leave the function. And if you take the timestamps, then now you have a way of getting the shell to print you out. It just did this thing and it took 200 milliseconds. Yeah. So if you have a correctly, nicely tight filtered set of I'm only tracing my fun in my mod, then that is probably safe that you can say DBG P of all processes, both existing and ones that will be created in the future, turn on call tracing for all of them. Because you're only going to get calls to this my fun thing. So any code that is not your code is not going to call this function because it's like the code server or something. It's never going to happen. Yeah, just I guess don't turn that on for a really high volume function that gets called in a loop. So I've done all kinds of crazy things with DBG traces and shellcode. One of the things I did is to trace calls that were happening on one system and then re-execute them on like a testing integration environment. I had a remote shell that had distribution connections to the production box and to the staging box, and I traced something in production that was getting a call of MFA, and then I used my little piece of shellcode, just took that MFA argument and did RPC call to the staging system and got it to execute there. So something would happen on production and then it would happen on staging, and I thought I was very clever. I don't think I even broke the system that time. And yeah, there in that eShellcode repository, there are all kinds of different traces that I've written for different things, like timing analysis in nets tables and all kinds of weird junk. Okay, so moving along again, this is about how I have managed to fix some Erlang systems. And I'm going to make a confession here, is that I have never successfully used a rel up. I have never successfully used an app up. I don't use releases. I'm pretty naughty about it. What I tend to do instead is compile in place on production systems. So usually we have it that we provision a new machine and then the chef thing clones a Git repo and runs rebar git deps compile in there, which means that when I need to fix something or change something, I can usually just go onto the node and go git pull, rebar compile, and then I can go into the shell and now I'm ready to like hot load a fix. Yeah. So that approach is probably not something that I would recommend for new systems, but it's an approach that so many people have used in the past that I think it's kind of worth talking about hot upgrade methods that kind of work with it. So hot code loading is really not hard. You get a remote shell to the thing, you've done the git pull, you've done the rebar compile, and the new code is sitting on disk, but the production system is still running the old code. Oh my gosh, I just have to type L and then the module name and hit enter and hope for the best. And again, if you're logged into your production systems, you can try that now. Hot code loading in a cluster, even easier. I only have to do this on one machine and I can break lots of them all at the same time. NL, it loads the version of module that exists on disk on the node you evaluated on and loads it on that node, and then it does RPC call to load the same module onto all the other ones, which I tend not to do because of the compile in place thing. I usually like to make sure that the version in memory and the version on disk are the same, and if you compile in different places, you get different modules. So I try and keep them the same. But if you are playing fast and loose, then NL is certainly a lot easier to do because you only have to do the like git pull rebar compile dance on one machine. The reason that I guess the other reason that I don't do it is that when you do this, it means that you have precisely one node that when restarted will come up with a fixed code, and you have the other rest of the cluster which will come back up with a broken code. So that's a good reason to make sure that your fixed module exists on disk in all places. Okay, so I'd just like to go to give you a sort of brief rundown of what I consider when figuring out whether I should hot load or not. There are kind of three classes of changes that I do on a regular basis. I change modules that don't implement processes. These are like library modules. They're the ones that are the closest to pure functional. Provided you don't remove an API that a process module is calling, then these things are perfectly safe to reload in production. No process will be killed by you loading that module. Anything that was in the process of running will just run the old version. Anything that calls into it after you load it is just going to get the new version, so this is really neat. If your bug is in one of your pure functional modules, congrats to you, because it's going to be really easy to fix. Okay, so changing processes that have state tuples. This is basically, you either have a top-level receive loop, or you are a gen whatever process. This is a little hinkier because if you change the interpretation of the state record, that moves you into the third and hardest class of changes to apply in a hot code update. But if you just change the functions in that module, and you know that when you load it, as long as any message that would come in next, like any handle call, handle info, handle whatever, if you could go from one version to the next and it didn't matter, like you would just start using the new version and you didn't have to fix anything up, then that's also fine to load. So if you've just changed the behavior of a handle info or a handle call or some other thing, that's okay to load too. The important point to bear in mind is that on the next message to that gen process, it's going to start using your new module code, because the old the gen code that actually implements your process, like not your callback module, but the gen server code itself, does external calls to your module. So they always take the new version. So every message is going to be an external call into the new version of your code. Okay, and then the last thing is that if you change the state record, like you change the number of elements in its tuple, that's kind of the trickiest thing to deal with. And that's what people usually write app-ups and rel-ups for. But because I am a very lazy person, and I tried to do it before there was rebar, and I tried to do it before there was like comprehensible documentation, I'm being very generous in assuming that exists now. Eventually, I got to the bottom of what app-up and rel-up was doing to upgrade fancy processes like gen servers and gen FSMs and stuff. What it boils down to is putting the processes that you want to upgrade into a special loop where they won't be making those external calls to your callback module, loading the new code, getting all of those processes to jump to the special change code entry point that you always leave blank in your modules, and then letting them all resume with the new code. So it turns out that you can do all of that by hand, and it's really simple. Okay, so yeah, long story short, you suspend the PID with sys-suspend. You load the new module. You call sys-change-code, and you pass it the process, the old version, which is an arbitrary term which gets passed through to your code change thing, the module name, which actually doesn't matter, and then the last argument is that extra variable that I've never actually really had much use for. So you do that, it will modify its state. The annoying thing about writing code change blocks is that you don't get the record syntax for the old version of your record. You only get it for the new one. So you usually have to do a stupid list to tuple, tuple to list manipulation, and then you resume. I have some practical examples, which are all links that you can go look at. And that's actually the end of my slides. Way. Okie doke. I guess it's probably the break now, so people can come ask me questions.
So if we can meet again at